Hello everyone, welcome to our chemistry presentation. This lecture is directed by Nicole Wren. Today, our topic is boron nitride is a compound that involved a large number of covalent bonds similar to the diamond. Well, as I said about the diamond, the first thing coming to our mind is that the diamond is shiny and has high density, which is it is very hard and not easy to break. Anyways, do not break a diamond. They are so expensive. Diamond is a covalent compound. Diamond is a covalent compound made by pure carbons. Covalent compound is two or more atoms bonding together, sharing electrons. In this case, the pure carbon atoms are forming a covalent bond. The covalent bond between two atoms in a given molecule are very strong as ionic bonds. In diamond, all the carbon atoms sharing one electron with each of their four neighboring carbon atoms. Diamond is one mineral that employs this structure. They are carbon atoms in a face-centered array plus an extra one at the center of each tetrahedron. At left, the relationship of the carbon atoms is to hydrohedra as shown. To the right, the carbon-carbon bonds are shown. This is the diamond structure in a different orientation, showing the tetrahedral structure a bit more clearly. The carbon atoms at the corner of the tetrahedra are dark gray. Those in the middle are light gray. This one is the diamond structure showing the carbon-carbon bonding. As we can see that the bonds closer to the viewer are shown thicker. Boron nitride is a chemical compound with chemical formula Bn, consisting of equal numbers of boron and nitrogen atoms. Bn, boron nitride, is isoelectronic to a similarly structured carbon lattice and exists in crystalline forms. The hexagonal form corresponding to graphite is the most stable and softest among boron nitride polymorphs, and is therefore used as lubricant and an additive to cosmetic products. The cubic variety analogous to diamond is called CBN. Its hardness is inferior only to diamond, but its thermal and chemical stability is superior. Boron nitride has been produced in an amorphous and crystalline forms. The most stable crystalline form is the hexagonous one. It has a layer structure similar to graphite. Within each layer, boron and nitrogen atoms are bound by strong covalent bonds, where the layers are held together by weak forces called van der Waals. The interlayer registry of these sheets differs, however, from the patterns seen for graphite because the atoms are eclipsed, with boron atoms lying over and above nitrogen atoms. This registry reflects the polarity of Bn bonds. As diamond is less stable than graphite, cubic boron nitride is less stable than H boron nitride, but The conversion rate between these forms is negligible at room temperature. The cubic form has spheroid crystal structure, same as diamond structure, and is also called beta BN or CBN. So let's talk about the preparation of the CBN, the cubic boron nitride. Synthesis of CBN uses the same method as that of the diamond. CBN, cubic boron nitride, is produced by treating hexagonal boron nitride at a high pressure and high temperature, much as synthetic diamond is produced from graphite. Direct conversion of hexagonal boron nitride to the cubic form has been observed at pressure between 5 to 18 GPa and temperatures between 1730 and to 3230 degrees. That is similar parameters as for direct graphite diamond conversion. The addition of a small amount of boron oxide can lower the required pressure to 4 to 7 GPa and the temperature to 1500 degrees. As in diamond synthesis, to further reduce the conversion pressure and temperatures, a catalyst is added, such as lithium, potassium, or magnesium. They are nitrides. They are fluoronitride. Water with aluminum or ammonium compounds, or hydrazine. Other industrial synthesis methods, again borrowed from diamond growth, use crystal growth in a temperature gradient, or explosive shock wave. The shock wave method is used to produce material called heterodiamond, a superhard compound of boron, carbon, and nitrogen. Like I said, cubic boron nitride CBN is the second hard material only next to diamond. It not only has many good characteristics of diamond, but also the advantage of high thermal stability and chemical interness to ferrometals. As the engineering material, it is widely used to process black metals. At the same time, due to the excellent heat, electrics, optical, and sound features, it is applied in a several, if high-tech fields, so that it becomes a kind of functional material with great potential market. After I said so many information, do you have a greater understanding of the diamond and boron nitride? Do you know what's the most common similarity of them? Well, it is boron nitride is a compound that involves large number of covalent bonds. So is diamond. That's why they share so many characteristics, and that's the most common similarities. Well, the time is almost over. Thank you for listening my presentations, and see you next time. Bye.